Multiplication for ages 10 to 11. Of course, multiplication and division are closely related because division is the inverse of multiplication. So, for example, because 17 times 3 is 51, 3 17s are 51, then 51 divided by 3 must be 17, and 51 divided by 17 must be 3. The children will continue to practice all the multiplication tables facts up to 12 times 12. It's a good idea to learn these as multiplication sentences. 1 times 12 equals 12, or 1 12 is 12, 2 12s are 24, 3 12s are 36, 4 12s are 48. Of course, it is important to learn the multiples, 12, 24, 36, 48, but it's a very good idea to learn the sentences. So, for example, if in a calculation they need to know quickly what 8 12s are, because they've learnt the sentence 8 12s are 96, they can get it very quickly. Their knowledge of tables will help them in learning about factors. Let's look at the factors of 12. We can make 12 using whole numbers by multiplying like this: 1 times 12, 12 times 1, 2 times 6 or 6 times 2, 3 times 4, 4 times 3. So these are the factors of 12. 1, 2, 3, 4, 6 and 12. But now let's look at the factors of 16. So we can make 16 by doing 1 times 16, 16 times 1, 2 times 8, 8 times 2, or 4 times 4. And we can see that the factors of 16 then are 1, 2, 4, 8 and 16. What are the common factors of 12 and 16? In other words, what's in both lists? Well, 1 is in both lists, 2 is in both lists, and 4 is in both lists. So the common factors of 12 and 16 are 1, 2, and 4, and the highest common factor is 4. It's the highest number that is a factor of both 12 and 16. So we've seen how to find factors, and here are the factors for the first 13 numbers. 1 can only be made by 1 times 1. 2, 1 times 2, 2 times 1, and so on. 12 actually has the most factors in the first 13 numbers, but as you can see, some of them only have the number itself and 1. The number itself and 1. Each number that can only be made by multiplying itself and 1 is called a prime number. And so we can see on this set of numbers, 2 is a prime number, 3 is a prime number, 5, 7, 11 and 13 are the prime numbers here, because each one can only be made by multiplying itself and 1. 1 is a special number, it's not a prime number, but the other special one is 2. Because that is the only even prime number. Every other prime number is odd. 2 is the only even prime number. The children will learn about multiples. So, for example, here are the multiples of 6. Within the tables, 6, 12, 18, 24, 30, 36, and so on up to 72. Going beyond the tables, 13 sixes, 14 sixes, 15 sixes, 16 sixes, all multiples of 6. And here are the multiples of 8. Up to 12 8s are 96, 13 8s, 14 8s, and so on. Now, what we may be interested in here are the common multiples. In other words, which numbers are in both lists. We can see that 24 is in both lists. 48, 72, 96, 120, and if we were to continue the list, 144 and 168 would be in both lists. These are the common multiples of 6 and 8, and we might be interested in which one is the smallest, the lowest common multiple, and that is actually 24. The children will be learning about square numbers and cube numbers. So here are the square numbers, or some of them. 1 times 1, which can be written 1 squared, is still worth 1. 1 lot of 1 is 1. 2 2s are 4. 3 3s are 9. 4 4s are 16. The little 2, so there, 3 squared, the little 2 shows that there are 2 3s multiplying together. Cube numbers are where there are 3 numbers multiplying together, so that's why there's a little 3. So 2 times 2 is 4, times 2 makes 8. 3 3s are 9, times 3 is 27. 4 4s are 16, times 4 is 64. 5 5s are 25, times 5, 125. Square numbers, cube numbers. Position value or place value is very important in relation to all number work. So we know about the columns, the units, the tens, the hundreds column, and next to the hundreds there are thousands, next to the thousands, the 10,000s, next to the 10,000s, the 100,000s, next to the 100,000s, the millions, then the 10 millions, and the 100 millions, and beyond that, the billions. But over to the right, we have a decimal point. The next column is the tenths, and then the hundredths and the thousandths column. The children will learn the effects of multiplying by 10, 100, or 1,000. If we look at a number 53, we multiply by 10, the 5 moves to there, the 3 to there, and the gap is filled by a 0. Try not to say we add a 0, but I'm happy to say we put a 0 on the end. So we've moved over to the left when we multiplied by 10. If we multiplied 53 by 100, we'd be moving 2 places to the left and filling the gaps with zeros. If we multiplied 53 by 1000, we'd be moving 3 places to the left. But let's look at a number that has a decimal in, 4.7. Multiply that by 10 and it moves 1 place to the left. And now 4.7 times 10 is 47. We don't need to put 0.0, we could if we wanted to. Let's try 3.8 and multiply by 100. So it's going to move 2 places. 1, 2, the 3 is going to be there, the 8 is going to be there, 3 hundreds, 8 tens, and therefore we have to put a 0 to fill that gap. So 380. 0.25, that's 0 in the units, 2 in the tenths and 5 in the hundredths. We've got to multiply 0.25 by 1000, therefore we're going to move 3 places in this direction. So the 2 is currently there, 1, 2, 3, that would put it there. The 5 will follow and fill in a gap with a 0. So 0.25 multiplied by 1000 is 250. The children will continue to practice multiplying 2-digit numbers, 3-digit numbers and 4-digit numbers by a 1-digit number. So for example, this is a 4-digit number multiplied by a 1-digit number using formal written short multiplication. 6,749, so we've got 9 units times 3 gives us 27, so 7 units and 2 tens. 4 tens times 3, 4 3s are 12, plus 2 makes 14. It's 14 tens, so we've got 1 for the hundreds. 7 times 3 is 21 hundreds, plus 1 more, that's 22 hundreds. 6,000 times 3, that's 18,000, plus the 2,000 we brought with us, so that's 20,000. So the answer to that question is 20,247. Looking at the long multiplication, they'll also be practicing these. Now here we always start by multiplying by the units. 2 times 8 is 16, so a 6 there and a tiny 1 there. 3 times 8 is 24, add 1 makes 25. 7 times 8 is 56, add 2 makes 58. 4 times 8 is 32, add 5 makes 37. You can see how important the tables are. It's very easy to do this calculation when the child is well aware of their tables. We're multiplying by the tens, so we put a 0 in the units column. 2 times 6 is 12. 3 times 6, 18, plus 1 makes 19. 7 times 6, 42, plus 1 makes 43. 4 times 6 is 24, plus that 4 gives us 28. Now we need to add up the 2 answers, because the top line is 4,732 multiplied by 8 units, and the lower line is 4,732 multiplied by 6 tens. Add up the 2 answers, so that's 6 there, 7 there, 17 there, 7 add 3 is 10, and 1 more makes 11, 8 add 3 is 11, 1 more makes 12, 2 add 1, 3. Final answer, 321,776. The children need to practice. Confidence in knowing how to find the answers is the key to mathematical success.